Okay, welcome back. Now in this part of the tutorial, what we're going to do is talk about one of the newest features in the latest version of Mental Ray implemented in Exercise 7. It's Mental Ray 3.6. One of these new features is called Importons. Sounds pretty strange, sounds like something out of some kind of a sci-fi movie or something. No, it's not some kind of laser gun. Importons is a new algorithm, a new tool in Mental Ray that allows us to optimize several different things that we used to render with in the past, and just make things a little bit faster. And it's just a little bit different workflow as what you may be used to in terms of traditional final gathering and global illumination. There's quite a few ways that we can use Importons in the latest version of Mental Ray. So in this video here, what we're going to do is start off by talking about one of the ways that we can use Importons to optimize the way that we work with traditional global illumination using a photon emission. So to get started, we'll open up an example scene. I'll just go ahead and go into my scene browser here, and the scene you're looking for is called Importons Start. So let's open that one up. And it's a pretty simple scene, just to get the idea here through to you and get moving along. Okay, so it's a pretty simple room with a few windows here. There's no environment or anything. And if I go ahead and do a test render of this, this is what we have. It's a pretty basic scene. If we go inside and render from inside the room, what we have is a simple room with a couple of colored walls. We have a yellow wall back there. Behind us is a green wall. The rest of the room is white. Just looks gray because it's kind of dark. And then we have this sort of cube in here in the middle of the room just to cast some shadows and interact with our soon-to-be indirect illumination. And then of course we have a hole in the ceiling here, and on the top we have a portal light. It's a regular spotlight which I converted over to a portal light, and we talked earlier previously how to set up portal lights. So it's a pretty straightforward, pretty simple scene, and you saw when we render we get something probably what you would expect. Alright, so before I get started on doing anything here, I first want to do a brief little discussion for about a minute on what Importons actually are. Okay? Alright, so you might be used to using global illumination, which is a pretty old indirect illumination algorithm in Mental Ray. Now, the way that global illumination works is photons are shot from light sources, in this case, this spotlight up here, and they're shot into the scene. The photons then bounce around, distributing different amounts of energy depending on what they hit and the distance that they hit it at, etc., etc., etc. Okay? Importons work in a very similar way, but at the same time they're a bit different. Importons are not shot out from lights in your scene. Nope. Instead, they work the opposite way of photons. Photons go from a light, they hit the scene, and then they go right into your eye by way of the camera. Importons are shot from the camera and hit the scene. In other words, they work backwards or opposite to the way that photons work. So that's how Importons work. Now, another important thing about Importons is that they focus on important areas of your scene. That's why they're called Importons. It's a name derived from the word importance. So what does that mean? You're telling me that Importons are work by the importance of your scene? That makes no sense. Well, let me try to explain that a little bit better. When you render out, Mental Ray is trying to pretty much decide what you consider to be important. So Mental Ray is going to use Importons to focus the importance of what's being rendered based on what's the most important thing in your scene. So you're probably wondering, wait, how in the world does Mental Ray know what's important in my scene and what's not important in my scene? Well, the way it knows is by reading your mind. No, I'm just kidding. Mental Ray's not at that point yet. But the way that it knows what's important in your scene is based on what you render. Basically, whatever you render has to be important. If what you're rendering wasn't important, you probably wouldn't be rendering it to begin with in the first place. So what Importons do is they figure, okay, if this 3D guy or girl is rendering out this specific frame or this specific angle with the camera, then that's probably what they want to render out, which is pretty self-explanatory, pretty basic common sense. So therefore, Importons base their importance on what the camera sees. So Importons, in short, are camera based. They're dependent on the view of the camera. So if my camera's facing all of this stuff over here, if I shoot out Importons, they're basically going to focus on everything that's visible to the camera and not what's invisible to the camera. In other words, what's behind the camera or somewhere far away in the scene where the camera can't see. So Importons are going to focus detail, and they're going to focus quality and speed on whatever it is that you're looking at. And this helps to speed things along and make things look a little bit better than they would if you're trying to go ahead and focus your quality and your speed on the entire scene, even if it's not viewable to the camera. Say, for example, it's behind the camera. So I hope that makes a lot of sense. Okay, so the next thing I want to mention is you're probably wondering, okay, great. So Importons is this new mental rate thing that helps with the quality, helps with focusing the importance of my photons based on the view of my camera. Fantastic. What exactly is it good for, and why should I use it? Well, there's a good benefit to Importons. Normally with global illumination, traditionally you would have to fire off millions and millions of photons into a scene to get a pretty decent result. This forces you to create some pretty big global illumination photon maps, and we'll be seeing that in this video. What Importons do is they optimize the map, and they can cut it down by a huge amount. In some cases, an Importon global illumination map may in fact take a traditional photon map that was, say, 100 megabytes, which can easily make mental ray crash, or can tax on some extra rendering time to your network render farm. And it could take that 100 megabyte size photon map and reduce it down to, say, 1, 2, or even 5 megabytes, which is pretty insane, while keeping the same amount of photons, which is fantastic. So it's a great new feature in the latest version of mental rate. So now that I talked enough, let's go ahead and let's start to follow up a lot of all this talking with some action. Okay, so first let's go ahead and select the spotlight, and let's open up its PPG. You can see it's a portal light. I'm going to go to the light parameters here, and under photon you can see that I have global illumination turned on. Right now we have 500,000 photons, 500,000, with an intensity of 100,000 up here. The color is pure white. Alright, let me close that. Let me go over here to render. Let's go to renderer options. Okay. Alright. Here's my GI tab over here. What I want to do is turn that on. And I'm going to leave the default settings, GI accuracy 500 with a search radius of 2.5 and a merge factor of 1. Now I'm going to go to a new tab in the latest version of mental ray and exercise 7, which is the photon global tab, and here we can switch again from global illumination final gather to radiance particles. We're going to stick with global illumination final gather. Okay, over here we have our regular trace depth and photon volume accuracy settings, which have been around with global illumination for many years. And then we have our new set of options here, which is what we were just talking about for the past 5 minutes, which is Importons. So let's go ahead and enable Importons. And you can see we have ourselves 4 settings. We have a density parameter, merge distance, diffuse bounces, and trace through geometry. These are the default settings. Let's leave the default settings alone, and let's turn Importons off. I just wanted to show you those settings really quick. What I want to do right now is I want to create a global illumination effect the traditional way without Importons. We're going to pretend that that we went back through time and we're using an older version of XSI. So I'm going to use the traditional global illumination method to illustrate a key point and when demonstrating the difference between old photon emission and the new Importon emission. Okay, down here for the photon map file name, I'm going to change the file name to something that we can recognize a little bit easier, and you're going to see in about a minute why that is. And I'm going to call this big underscore GI. So it's going to be big GI photon map. Hit enter to go ahead and finalize that. Okay, make sure rebuild is on. It should be on by default, and make sure that Importons is turned off. I don't want them on. Okay, now what I'm going to do is I'm going to come into my scene here, and let's go ahead and perform a render, a preview render. So here we go. We're emitting photons over here, 80%, whatnot, 500,000 photons into our scene. Pretty straightforward, pretty fast, pretty simple little example here. And here we go, rendering. Alright, so there we have some global illumination. We can see the splotching, the classic splotching here from the photons. And there we go. Okay, I'm going to turn rebuild off. And now what I can do is just go ahead and rotate around my scene, and you can see that when I do this, the effect is not view dependent, meaning that the global illumination effect is for the entire scene. So I can freeze it by turning rebuild off, and then I can just turn my camera around and I can render from any angle without having to compute the global illumination algorithm over and over and over again. Okay, this is pretty traditional behavior of global illumination, which is pretty straightforward, probably what you'd expect, especially if you have experience with global illumination. Okay, so that's great and all. Let's go ahead and close that. Now what I'm going to do is something a little bit different here. Let me go over to, let me grab my light. There's my spotlight. Just open up the PPG there. Let me go to photon. I'm going to go ahead and emit 1 million photons. So that's a 1 and 6 zeros. That's plenty of photons for this scene. Let me go ahead and open up my renderer options again. I'm going to turn on rebuild. I'm going to render again, this time with 1 million photons. And I'll just skip ahead so you don't have to watch this. Okay, there we go. Not much of a difference, but we did emit more photons. Took a little bit longer than before, but not too long. This render didn't take too long to render in total. Okay, so I'm going to go ahead and freeze that. And now again, I can just come over here and render from any angle, and I'll be good. Okay, so let me close the render preview there. Alright, the next thing I want to show you is the size of the global illumination map using traditional photon emission. Let's hit 5 on the keyboard to open up a browser view. Let's go to our render pictures folder, which is the default area where XSI will save out your photon map. And here's the photon map, big GI photon map. It's 9.1 megabytes big. That's a pretty, well, it's not really a big photon map, but for a full production scene, don't be surprised if you end up with a photon map that's 100 megabytes, maybe even more. So 9 megabytes isn't that much, but this is just to illustrate a point. Now the next thing I'm going to do is I'm going to turn on the Importons, and I'm going to leave it at the default settings, which has a density of 1, merge distance of 0.2, no diffuse bounces, and it is set to trace through geometry. I'll talk about these settings a little bit later. Right now I just want to illustrate one key point to you. I'm going to turn on rebuild, and now what I'm going to do is we can be facing this angle right here. I'm going to go ahead and do another render, and you can see that it's emitting Importons first. The Importons are emitted first before the actual photons. Once the Importons are done, mental ray is going to use that, and then it's going to use it to help it calculate the global illumination and localized effect based on what you see. So it's going to be a more optimized photon map in the end. Once it does that and it no longer needs the Importons, mental ray is basically going to take those Importons and simply discard them. It's going to throw them away. I don't need them anymore. I'll stick with my photons. So the Importons are just there for the beginning to help out the photons, and then after that they're pretty much thrown away. Okay, so this is what we get. Our lighting looks actually a little bit more realistic. Our shadows are a little bit more accurate back here. We do still have some splotching, but that's of course because we have such a low number of photons. We only have 1 million photons, which sounds like a lot, but when it comes to workflows of global illumination, if you have any experience with that, you will know that it takes a large amount, I'm talking millions and millions of photons to get a pretty decent result. But you can see that our shadowing looks a whole lot better than before, and this is because of course the Importons are helping to increase the quality by that much. Okay, alright, so there we go. That rendered pretty quick, didn't take too long. I'm going to turn rebuild off. Now what I'm going to do is I'm going to go back to the browser, go back to render pictures, and let's have a look at the big GI photon map. Oh my goodness, look at that. It's 1.1 megabytes. It was reduced by a large amount. This thing is almost a tenth of the size of the original. So using traditional global illumination created a less accurate, not so good photon map with 1,000,000 photons, and on top of that, to make matters worse, it was huge. It was 9.1 megabytes. The Importons came in, helped to clean up the photons and make them a little bit more accurate in terms of the shadows, which we saw in the preview render before. And on top of that, the second big benefit and the main benefit of using Importons with global illumination is the fact that it reduced the size of the photon map from 9.1 megabytes to 1.1 megabytes. That's huge. I mean, even if it cut it down by 50%, that would be huge in itself. But this thing's cutting it down by almost 90%. It's insane. So this thing's great. So now a file this small, if it goes out to, say, a network render farm, is going to help the lookup of the photon map, and it's going to help out with the network rendering and the distribution of the files over the network. And essentially, your render is going to render out a lot faster. Your animations are going to go out a lot faster through the door. Okay? Now, there's one key thing to note about these Importons, and I'm going to show you that in a moment. I turned rebuild off. Let me go ahead and render again and see how fast it renders, because the Importon map is frozen, or the photon map, I should say, is frozen. Okay, so here's our global illumination effect with Importons. Looks great, right? We have a little bit of a problem. See, since the Importons are camera dependent, they're view dependent, they're dependent on where the camera is viewing the scene, try to guess what's happening behind the camera. And I'm going to show you now what exactly is happening. With rebuild turned off, so it's frozen, let's just go ahead and rotate the camera around like this and look at the opposite side of our room. And it's going to go ahead and refresh. Uh-oh, we have a serious problem here. What in the world happened? Well, what happened is that the Importons basically took the photons and concentrated them on what the camera's looking at. So we have 1,000,000 photons. The Importon said, okay, let's take this 1,000,000 photons and let's concentrate it on what the camera's facing. That's a very simple and basic way of looking at how Importons are deciding how the photons are going to go ahead and be rendered out in our scene and calculated. This is a good thing because, of course, it gave us a nicer render than before, and it reduced the size of our photon map by a considerable amount, and that's an understatement. But the problem is that it took away from the rest of the scene, so now we don't have any photons in the back of the scene. It's just pitch black like so. So that could be a big problem. So how can we get around that problem? Well, there are ways of getting around that problem, and I'm going to talk about that a little bit later. For right now, though, I'm going to go back to the basics, and I'm going to go ahead and explain these parameters over here under the Importons section of the PPG here for the mental ray render options. It's a little bit beginnerish, I know, but because this is a new feature in the latest version of XSI 7, I have to go ahead and cover it for you. I'm not just going to leave you there hanging and leave you guessing what in the world is density and what is trace through geometry. Let's go ahead and go over these options first. And once we have those basic fundamentals down, we'll go ahead and look at an advanced technique to getting this right here in our preview render, this blackness here, to not happen. Okay, so let me close that. And let's go ahead and let's talk about these parameters right now. Okay. So the first option, well, besides the enable option, which is pretty self-explanatory, it just turns the feature on or off, is the density parameter. So what is density and why is it set to 1? Well, the default value is 1. I recommend that you use this default value for your final production scenes. You're probably thinking, wait, the default value for my final production scenes? Yes, you heard me right. This default value means that the photon density is going to be set to 1, and this density is dependent on the pixels on the screen. Like I said before, the Importons are not based on the entire scene, they're based on what the camera views. Therefore, this density parameter is set up to work with the number of pixels on the screen. It doesn't work with the number of photons, it doesn't work with the scene size or any of that stuff. It works with the pixels that you're rendering out in your final render. If you set this to anything below 1, it's actually going to reduce the quality of the photon map in the end result. So it's going to speed up the emission of Importons. As you saw earlier, if I hit rebuild and do another render. Here's the Importon emission stage right there. See it? Let me go ahead and stop that. If I come over here to the density and I were to lower this density to anything below 1, it's going to go ahead and it's going to speed up the emission of the Importon. So if I drop this to the lowest setting, which is 0.025, okay, and I go ahead and I refresh this, you notice that the Importon emission was practically instant. It was actually very difficult to see. It just said emitting Importons, boom, and it just did it in about the blink of an eye. So it was really fast. Unfortunately, by reducing the density, we reduced the quality of the overall photon map, so it's not going to look that good. And you can see here in the render, it looks pretty much like garbage. This is totally unusable for any production. It even looks horrible for a preview render. So reducing the density is going to speed up the Importon emission process, but it's going to reduce the quality. And in this case, our quality has been reduced to pretty much rubbish. So what we need to do is increase the density. The default parameter of 1 works out just great because this is going to create a very large number of Importons per pixel, which is, if I come over here and render this again, which is why the Importon stage takes a little bit longer right there, which actually doesn't take that long. Of course, the more photons you have in your scene, the longer the Importon emission is going to take. Also, because the Importons are dependent on the pixels that you're rendering out, right now you can see that I'm rendering out a test render image of 400 by 270 pixels. If you were rendering something at, say, 2000 pixels by 2000 pixels, 2K or 1K or 3K or 4K, your render is actually going to slow down by a large amount, and that's because the Importons are view dependent, and they're dependent on the pixels on the screen. So the more pixels you're rendering out with, in other words, the larger the image size here, the longer the Importon emission is going to take. So you can take and tweak these settings to whatever you like and play around with them till you get a good balance of quality and speed. I strongly recommend you keep the density at the default level of 1. And I strongly recommend that you don't go higher than 1. 1 is good enough, trust me. If things are not looking good, it's probably because you don't have enough photons being emitted by the lights in your scene, and you should play around with the global illumination accuracy. So if you go to the GI Caustics tab, you can see the global illumination accuracy right here. Tweak this setting and tweak the photon search radius as well as the number of photons being fired out by the light or lights in your scene. Don't increase this density because it's really past 1. It's not really going to increase the quality by too much, and it's going to tax on a lot of extra rendering time, which is not optimal and not very smart to do. So let's keep that at 1. Then down here we have a merge distance parameter. The merge distance parameter basically tells the Importons to merge based in world space in terms of the size of this merge distance. So what does that mean? That means that this is going by the units in Softimage. So this doesn't mean 0.2 in terms of the camera space. It means 0.2 in terms of world space. So this is literally 0.2 units by default. 0.2 Softimage XSI units. Okay? And the merge distance, basically any Importons that are within this distance are going to be merged and averaged out, which is a good thing because it helps to smooth out blotching and artifacts and things like that. But you don't want to put it too high, of course, because then you'll reduce the accuracy of the actual Importons. So you want to keep this at a pretty low amount, not too low, however. The default is set to 0.2. I wouldn't really go with the default. We can go ahead and try tweaking this up even higher than 0.2, but not too high. One thing to make note of, if you knock this down to 0, you basically turn photon or Importon merging off. So let's go ahead and let's do a test render of that. Okay, so this is what we have. If you notice, not much of anything happened. So why is that? I turned the merge distance off, so how come it didn't change or update even though I just re-rendered this? Well, there's actually a little secret, a little trick to this. Let's go ahead and go back to the GI Caustics tab over here. It turns out that this default photon merge factor under the global illumination options is controlling the actual merging. See, this is one merge parameter, merge distance here. Then over here we have another merge factor. And this works a little bit different than the merge distance parameter from Photon Global. This is the one from global illumination. When you have this photon merge factor turned on to anything past 0, it basically works like a switch, like a light switch. When it's at 0, it's off. If it's at anything other than 0, so anything above 0, it'll go ahead and turn on. When this parameter is turned on by going above 0, it actually turns this parameter off, the merge distance here, behind the scenes. So it doesn't matter how much you turn up this merge distance, it's not going to make a difference because over here the photon merge factor is turned on. So let's go ahead and put this back to the default of 1. Go back to Photon Global here and we'll max out the merge distance to 5, and we'll do another test render. Video editor, there was a mistake there, pretty big mistake back when I started talking about the merge distance. Go back and edit all that stuff out about the merge distance. I'm going to talk about the merge distance here. Again, I'm going to start over in 3, 2, 1. So the next parameter down here is the merge distance. Now what's the merge distance? Well, first of all, you need to know that the merge distance works in world space, meaning it works in Softimage units. So this default 0.2 means that this is actually representing 0.2 units in Softimage units in the actual grid space over here in your viewport. Okay, what that means is that any importons that are within that distance or closer than that distance are going to go ahead and they're going to merge. They're going to merge together to average this out and make this look nice and smooth. Right now it's kind of blotchy, but it's actually pretty smooth. If I go ahead and I increase this merge distance, just going to pick a random number by moving the slider up here, so about 2.356, you're going to notice that we're going to have a pretty big difference. And that's the difference I was talking about. Well, this looks horrible. What in the world happened? What happened was that my merge distance is too big. So now the importons are not merging together correctly because they're too separated. There's basically this merge distance parameter that's saying, hey, you guys can't merge and smooth out this image because you have to be within this threshold here for that to happen. So it's not good to have this number set too high, or else you end up with something like this. So the best option is to stick with the default. Of course you can lower it more if you want to, but I like to stick with the default because, to be honest with you, unlike global illumination and final gathering, the Importon's default settings are actually pretty good. They're actually set up for a high quality render. Okay, so we'll just re-render that back out at a merge distance of 0.2, so it looks better. Alright, then we have down here this Diffuse Bounces parameter. By default it's set to 0. That usually is not a good thing. This is the one default parameter with the Importons here that shouldn't, probably in most cases, shouldn't be set to 0. It's not really a problem if you leave it at 0, but in most cases you may want to increase this past 0. So what is this Diffuse Bounces? This is also known as trace depth in terms of Importons. So let's see how this works. What do the Diffuse Bounces do? Well, I could sit here and give you a cryptic explanation, or I can just show you. Let's go ahead and show you. Okay, what I'm going to do now is, let me see here, I'm going to go ahead and actually lock down this render, and I'm going to leave it. Okay, like we saw earlier, Importons are camera or view dependent. So right now this looks pretty good, but behind me, what in the world is behind me? Let's see what's behind me. Okay. Before I do that though, I'm going to save this camera viewpoint here. I'm going to go up here to my camera recording buttons up here. I'm going to middle mouse button click on the first one there so I can save this view angle here for reference in a few moments. Okay, so let me go ahead and just collapse and tuck away that first render, And I'm going to turn the camera around so that we see the opposite side of where we were looking at before. So now we're going to be looking at the opposite side of the room over there. And with rebuild turned on, what I'm going to do is go ahead and do another test render here. And now this is going to show us what we saw earlier, which was that that problem with Importons, where whatever's behind it or whatever's outside of the view of the camera is not going to have global illumination dedicated to it, which basically just leaves that pitch black, those big pitch black dark areas, which is no good. Okay, so there's no black right here, and that's because Mental Ray has this new adaptive feature where when there's a problem, when the feature doesn't work, it automatically fixes itself without you downloading any updates. No, I'm just kidding. I wish it worked that way. It doesn't work that way. What happened here was a pretty happy accident. I left my rebuild option turned on. So when I turned the camera around and rendered again, I didn't get the blackness because rebuild was on and Mental Ray went ahead and calculated the Importons all over again. So let me do this. Let me go back to my original camera view here, and I'm going to have to render this again. So let me just re-render and pause the video. Now I apologize for that, but nobody's perfect, right? Everybody forgets things sometimes. I'm sure I'm not the first person in the world to have forgotten something. You know, leave your keys in the house, keys locked in the car, or something like that. Actually, that's never happened to me before, but when working in XSI, I sometimes forget to turn an option on or off, especially little tiny check boxes like this. So I'm going to turn the rebuild off this time, and now I'll turn my camera around and look at this from behind. And this time what I'll go ahead and do is I'll open up a new render preview and leave the original one locked down. So I'll render again, and this is what we've got. Here's the area that the camera was able to see, but then this is behind the camera where we were not able to see, so there was no global illumination dedicated to this area over here. Due to the case that we're using Importons. Okay, so it's pretty much what we expected to happen. Now we're going to see how we can use the diffuse bounces to help alleviate this problem. It's not going to solve the problem entirely, but it's going to help to alleviate it just a little bit, or a lot, depending on how much diffuse bounces we use. So I'm going to close this preview. I'm going to keep this one here, and what I'm going to do is with my camera still looking from this angle, I'm going to middle mouse button click the second camera recording option up here. That way I have view 1 and view 2. So let's go back to view 1, which is the original here. And what I'm going to do is I'm going to turn rebuild back on, and I'm going to take the diffuse bounces. I'm just going to go ahead and crank that up all the way to 20. Okay? And we're going to see what happens. We're going to go ahead and refresh this and render again. There's the Importons. Doesn't take too long to render. Renders out pretty fast. Okay, so it rendered out. Now, from our first angle here, our first view, it pretty much looks the same. Not much difference, right? Okay, now what we're going to do is we're going to go ahead and turn rebuild off. This time I'm not going to forget. Turn that off. Robo, you should be reminding me about these things more often. Then I'll go over here to the second camera viewpoint over here, and I'm going to perform another render. And this is what we have. Now, it's a little bit hard to see. We really can't see it too well. There is some indirect illumination going on in the back over there. Not a lot. It's still pretty dark, but it's not pitch black like it was before. Now you can actually see a little bit of the wall there, some blotching there from the photons. So basically, let's close that. And we might as well just close this one as well. Basically, what turning up the diffuse bounces does is it increases the amount of times that the Importons can bounce around in our scene, which can be a good thing. And it really doesn't add on too much extra rendering time, but it does add extra light bounces in our scene. So I like to increase that past 0 in most scenes in order to get them to render a little bit better. But we still didn't get a good result. As you saw, the background there had plenty of black, plenty of dark areas there where pretty much there's light that's unaccounted for, which is not realistic and not very good. It's not what we want. So what can we do to fix this problem? Well, that's where this trace through geometry option comes in pretty handy. Trace through geometry does pretty much what it says. When it's on, which is the default option, and it's what I strongly recommend you do, the importons actually go through objects. They don't stop at an object. So for example, if an importon goes through this cube object right here, let me just hit back right there and lock that PPG down. I don't want it going anywhere. This cube object right here, right now with this option turned on, trace through geometry, the importons are actually going to go through it and to the other side. That's a good thing because now I'm going to have some importon and indirect illumination. Video editor, there was a strange sound. Let me just go ahead and repeat the last thing I talked about right now in 3, 2, 1. So with this option, this trace through geometry option turned on, the importons are going to fire from the camera and they're going to go through this cube right here and into our scene. That's a good thing because that means that importons are going to be calculated behind this object, which is good. We get more accurate lighting and we get a better overall effect with these global illumination importons. Alright, so we want to make sure that trace through geometry is turned on. You can turn it off if you want, but to get the best results I recommend you leave it on, which is the default option. So now that I've finished talking about that, let me just end this video here because it's been going on pretty long, and in the next video I'll pick up and we'll continue and wrap up this whole little video segment on importons in the latest version of XSI.